Hi everyone. So today we continue with variables. Numeric types got wrapped up last time. So we're going to be going about Boolean types. So let's get Visual Studio Code opened and let's get rolling. Okay, I'm going to open up Visual Studio Code. Go to File, Open Folder. I'm going to create a folder called Boolean Types. Terminal, new terminal, .NET new console. Okay, so here's our program. I'm going to get prompted to enable debugging. I say yes. Okay, so we don't need that hello world line. So Boolean types, what are they? So Boolean types are basically data types that are logical, that can have two literal values of true or false. So Booleans are logical types that can be either true or false. So let's see some examples. So I'm going to create a Boolean, some Boolean. If we don't do anything to that Boolean, let's see what's inside without us doing anything. Okay, so C# doesn't allow you like numbers to write out the Boolean variable without actually specifying what's inside. So we can say false. So when we run this, you see that it writes out false. Booleans can also be declared like so. Boolean, some Boolean 2 equals true. So both the bool and boolean are acceptable when you declare variables. So the other one is true. Let's run this. So there it is. What's interesting about booleans that you cannot convert them implicitly to integers and vice versa. So let's see. So I have integer, let's say number, and I set this equal to some boolean. You see, it doesn't allow me to implicitly convert. But if so implicit conversion, implicit does not work. From boolean to integer and from integer to boolean. I'm going to demonstrate the other one shortly. So what can you do? Well, you can do convert to int32, which is another word for integer, some boolean. And just to remind you, implicit conversion is the one that happens automatically. So this doesn't allow you to do that. This is an explicit conversion. You actually say, this is what I want. So let's see. So we have some, let's do this twice for also for boolean 2, so you guys can see how this works. And now let's write out console write line. What do we get for number? And then what do we get for number 2? So let's run this with F5. Oh wow, so look, for Boolean that is false, it converts to a 0. And for Boolean that is true, it converts to a 1. Let's see the other way around. So let's say int number 3, let's assign this some number like 1025. Then we have int number 4, let's assign it to 0. I just want to demonstrate something to you guys. Alright, so let's take another Boolean, some Boolean 3, and we're gonna say equal to 3. You guys will see I get the same error. Implicitly I cannot do it. So convert to Boolean 3. Let's do the same thing for the other one. And then let's display this out. So I'm just going to copy and paste this so it'll be faster from the lines above. So we go 3 and 4. Right? So let's run this and let's see what happens. So look, number 3, which was set to 1025, evaluates to true, and number 4 evaluates, which was 0, evaluates to false. So the rule when you do the other way from integers to Boolean is that anything outside of 0 we evaluate to true, and anything outside and 0 basically evaluates to false. So this is important to keep that in mind. You guys notice that we had, when we assign variables, we use the equal sign, right? This guy, right? But you know, this doesn't really behave like an equal sign. This doesn't behave like an equal sign. This is an assignment operator, right? So how does equal work, right? What is equal in C#? So to see if two things are equivalent to one another, we use double equal. This means equal. And single one, this is an assignment. So when I write console write line, let's write some Boolean equal to some Boolean 4. And then we can do the same thing, but for number 3 and number 4, just to show you that you don't really need to be in Booleans to check if some things are equal. So let's run this with F5. Oh, debugging, problems, something. All right. What doesn't it like? Oh, see, I missed a semicolon. Yeah, there we go. So you see, when is Boolean equal to Boolean 4, 3 and 4? Nope, because one is true, one is false. And the number 3 is not the same as number 4. You also have other comparison operators. That's what we call them. Equal is a comparison operator. Other comparison operators are greater or equal to. You also have less than or equal to, greater or less than. So let's just do an example. So let's say console write line. Let's say is number 3 greater or equal to number 4. Remember 3 was 1025 and 4 is a 0. So let's see what this says. We look at the last clause. Yep, it's true that this is the case. So these are comparisons of value types, right? Comparing reference type. Let's compare reference type. So basically let's compare objects. So let's create a class called person. All that class will have is a name, let's say a person name, right? So let's say string person name. And when you declare that person, you're going to pass a name, and we're going to assign this to the person's name private. So person name, it's a private. That means it cannot be changed outside the methods of the class, which is sort of neat, and I will go in more details when I discuss classes. So we're saying person name equals name. So here I have to define which type of parameter is name, so it's a string. So let's work with this. So I have a person. Let's say person 1, and we're going to say new. Doesn't like it. Oh, okay, so it's new person. Alex, right? Let's do another person. We're also going to call him Alex. So what does this do, right? It creates a person named Alex, and at the same time, it assigns the name, which comes here and sticks the name inside person name. So why did I do it this way? Why didn't I just expose this? Why didn't I just make this public? The reason for this is that you don't want people to do this. Person 1 dot person name. You don't want them to change the name of a person here this way, right? If I will make this public, look what happens, right? So now this is good. So I can say Tom, right? I can change the so you're trying to play a little control game here, and isolate the user from themselves, because some things you don't want the user to change, and when they change, they can damage some logical structure that you have, right? You know, it's people don't simply just change names. You have to go to the court system. So there's a reason why you want to hide special functionality from a person. So by making this this person name by default is private. So private, this is not allowed. So only when you declare. So you have these two people, person 1 and person 2. They're both named Alex, right? So let's check. Console write line. So it's person 1 equals to person 2. Right? Let's check this out and let's see. No, they're not. Which makes sense if you think about it. Two people named Alex don't mean that this is the same person, right? But if I create another person, person 3, and I point it to person 2, so person 3 is exactly person 2. So if I do this, person 2 and person 3, watch what happens. I get a true. So that's something to think about. All right, so going forward, then we have something called conditional operators. So what is conditional operators? They are and or. So it's a double %% for and 2 pipes for or. So what this means that you can check if expression is true, right? So console write line. Let's demonstrate an and. Right, so let's look at some Boolean and some Boolean for, right? So some Boolean and some Boolean for. So basically, some Boolean has to be true and some Boolean for has to be true for this whole thing to be true. So let's see if that's the case. It's false. Why? And now let me show you something. I took my mouse and I left click on line 42. Now watch what happens. I'm gonna run again with F5. This is called debugging. So you see, this is a bookmark that I set in the code. So I want the execution of the program to stop. So now I'm saying that these two things have to be true for this to be true, right? So what's happening? So when you hover with your mouse over some Boolean, you see this one is true. You can see above the variable name, it shows you on hover what it is. So this is true, right? But this is false. So both of them together are false. You can also you see that line on the bottom, you can actually type out and press enter, and it will tell you also what that is. Another thing you can see on the left side in the upper corner, you also have the variable values here. So you can see the snapshot of what you're dealing with. So you see that some Boolean 3 and some Boolean 4s 4 is true or false, true and false. So that's why this whole thing is false. So this is a little bit intro on debugging, and I'm gonna go in more details in a later lesson. So this is like a DVD control. So you can stop, pause, and continue. So F5 is continue. The program finishes running. So let's try to get a true here. So let's see a where we had true. So we had number 3 was a Boolean tree was true. So some Boolean 2 is true and some Boolean 3 is true. So let's show you another end demo. So we have 3 and 2. I know both of them are true. So let's run this together. You see the expression evaluates to true. And now let's do an OR demonstration. Let's take out that bookmark. So OR means either of them is true, the whole thing will be true. So when we go here, notice on AND this thing was giving us a false. Now let's see what happened with the OR. Yep, one of them is true. That's all it's needed, and the whole thing evaluates to true. Then also we have negate operator or invert operator, which is an exclamation point. So just to show you how this works. So I have true, right? But if I invert it, I will get a false. So you put the exclamation point before the variable and you see what happens. So here you had a true, I inverted, what do you think you're gonna get? You got false. Right? So this thing has its uses. Another thing I want to show you guys, there's something called ternary operator, which goes in this format: expression, do this when true, do this when false. So a simple example. So let's do an expression. So is true equal to false, right? So you can say true is never equal to false. Or true is equal to false. So what happens here, right? So it checks is true equals to false. If that is true, this will run. If that is false, this will run. So let's run this. True is equals to false, right? Actually, I have them switched around. So let's go here. Yeah, you see, this is also important that You know, you're in control when you program, right? So if you put a nonsense in like this, it's gonna come out. It didn't give you an error or anything. It runs. So basically garbage in, garbage out. So let's run this again. True equals to false. True is never equal to false. So now it correctly evaluates. And one thing about this is that this is very useful because you can write this like in one line. You know, it's very convenient, and many times people use this. Many times people use this in their code. And let me just show you quickly a function. So let's say let's do a comparison. Let's find out if a number is even, right? So static Boolean is number even, right? And so it's going to take in a number, right? Let's search. So check if a number is even. Then this is number to be checked. Returns true if number is even. If number is even. Just for a reminder, if you put 3 slashes in front of a method name, it will give you this template that you can fill out information. So when someone calls this, it will give them a result, right? So how can we, what do we need to do? So we will return number divisible by 2, right? Equals we're checking if there's a remainder. If there is no remainder, it's false. Else is true. Okay, so I made a mistake here. All right, so the number divisible by 2 equals 0, right? That's what we want. Notice that they stopped me here because you cannot implicitly convert, right? But I can do this, right? Okay, so that will be allowed. I misspelled Boolean, yeah. Unforgiven. So this is allowed, but this looks a little like awkward. So it's better to say number modulo division by 2, is that equal to 0? So if there's no remainder, that means it was divisible by 2. So now, so you can see how the ternary works, right? So let's say console write line is 5 even, right? So let's call is number even. Why? Okay, so is, let's pass in 5. So let's see that little program if it works. Is 5 even? It's true. Oh, you see again, I had a mistake on the condition. So if there's no remainder, it should be true. But if there's a remainder, it's false. So be careful. You know, it looks good on paper, but it doesn't mean it's good. So let's run this again. So this is another thing I want to tell you guys how I code, right? I frequently test my code when I run it, because when you make a mistake, it's easier to catch it because you have less to work with, as of supposed to you write thousands of lines and then you run it and then you go like, oh, where did it go wrong, you know? So this is a good practice to do. So that's an example of ternary, and I just want to show you an example of like a multi-line ternary example. So you can do, let's say, console, right? So this is gonna take a few lines. So you can say true equal to false, right? Or so true equal to false. You can say, let's just say 1, right? Or if it's not, if this is not true, then you can say again, are you sure? True equals false again. And then you can say 2 else 3. Oh. And you can keep going. So what does this means? Like true. Okay, this needs a semicolon, right? So you can keep going with this. Look, true equals false. If true, do this. If false, do this. So this asks me again, is true equal to false? If true, do 2. If false, do this. So you can keep putting these things in there, as many as you like, for both conditions. So you can do one also for here. You don't have to write 2. You can have another condition. So this can be infinite. So, but the problem with that, if you're going to put too many here, you can get confused what goes with what, right? So what you might end up doing is like do some sort of indent game to find out what happens when you pick one over the other, so you know how things are aligned. So this can be pretty confusing if you put too many, but you know, just keep that in mind. One important thing I want to talk about, what Boolean allows you, is something called short circuit. So what is short circuit? Basically, the current gets cut off, and there it is, right? The flow of current is broken. So what short circuit is, basically, the moment C# knows that the expression will evaluate a certain way, it stops checking further and proceeds. The same thing happens with JavaScript and I'm sure other languages. So the moment C# knows that the expression will evaluate a certain way, it stops checking further and proceeds. Why this is important? So think about something like this. So you run a console write line. So you want to say something important message, right? Right. So let's say true equals false, or true equals, let's say number 3, Boolean Tree, right? Then do this, go home, or say right. Silly, but I'm going to demonstrate you how powerful the short circuit is, right? So think about that. The first condition is very simple to check, right? But the second one, let's say some Boolean is this complicated logic that is checking millions of things and returns you a value, right? This thing can run for a while. So basically what this thing will do, since this is an OR, so let's do true versus equals to true to illustrate this, because this will evaluate to true. So true equals to true is true, or in event of OR, the whole expression is now true, so it doesn't go and check this anymore. So your program is more efficient, right? If I can also do the reverse, right? So I can put this thing over here, or but now I did something, I do the heavy lifting first, and then I check versus the easy. So let's say this evaluates to false. So I spend all this time and I get a false. So it keeps going, and this one is true, and it's you get go home. So it's really important, the positioning of these conditions. So you want to put the lightest one on the left, because they prevent your program from going through this whole hoopla of this extensive checking. So this is a very important concept for performance. And just to wrap up, besides and or, you can use other operators. You can use this for and this for or. But the problem with them is that they don't short circuit. They're used mostly for bit-wise operations, which basically most of the times you will not use this. In all my development days, I don't even remember if I used this more than once or twice. So these guys are not used much, and they do not short circuit. So you can do this. Number 2, or number 3. You can do this. Fine. But these guys will not short circuit. So let's run this. So number 2 or number 3. Okay, this does not even show me. Let's put double parentheses. Let's see. So it's 25. Let's do both. Let's see if this will be any different if I go like this. Yeah, there is. So you see this also behaves differently, right? This allows you this comparison. But this is not allowed, right? So let's put a breakpoint in there. Let's not leave this unturned, right? So what's happening here, right? So number 2 is 1. Number 3 is 0, 1, 0, 2, 5. So let's run this. So this also works differently than the other one. So, but let's do something. Let's do a 0, right? That'll be more concrete, right? So let's see what happens here. Let's stop this bookmark from going. All right. So here it gave me the condition that is true, right? So here it says 0 and number 3, so give me a 0. And here's 0 or the number 3, and give me the number, right? Let's see if we put it in the reverse order. Would that make any difference? Yeah, this is typically not used. So, but this is used mostly for bitwise operations. When you're comparing bits, unless you're going to be doing that type of programming, you're not going to run into this at all. Yeah, so it's the same. So just keep that in mind, right? Keep in mind that these guys exist. They do not short circuit, and they behave differently than the double and percent and or. So that's it for now, guys. This wraps up the Boolean types. Thank you so much for watching. Please subscribe. All the best. Bye bye.